Hi, my name is Denny Cook, and I serve as the Math Specialist for Regional Office of Education number 40, which serves the counties of Greene, Jersey, Calhoun, and Macoupin here in Illinois. Today we're going to talk briefly about a topic that many of you have probably heard about and may not know a great deal about, and that is the Common Core State Standards in mathematics. The first thing we probably ought to mention is what the Common Core actually is. The Common Core is a set of standards that is really a national set of standards that currently 48 states have adopted, including the District of Columbia and 2 of our territories. It is a set of standards that is rich in rigor and that therefore demands higher order thinking skills for students. We've built this whole experience on the experiences and lessons that we've learned from the original Illinois Learning Standards, and it's internationally benchmarked, meaning that we used a lot of the information from countries where students have outscored our students in mathematics as well as English language arts on a consistent basis. And it is based on evidence and research. The key shifts in the Common Core State Standards for mathematics are the 4 that are listed on the screen right now. The first of these is focus. When we talk about focus, what we're talking about is creating a much more narrow focus or field for the study of mathematics in a given year, but we are going to create it at a much deeper level. So instead of teaching a mile wide and an inch deep, what we're really talking about is creating deeper understanding for our students, but not trying to cover a million topics in 1 year. It includes a strong foundational knowledge and deep conceptual understanding for our students. Second of these is coherence. Coherence is an extremely important concept, especially in the field of mathematics. What we want to do is make sure that learning is connected within and across grade levels. Standards are going to be nothing more than extensions of previous learning that students have had. Mathematics is a spiral type of learning arrangement, and so students have to learn the previous material in order to be able to understand the current material. Third, we talk strongly about rigor. When we talk about rigor, we really are interested in hitting on 3 major categories. One of these is fluency. Fluency refers to speed and accuracy. And when we talk about speed and accuracy, what we're really meaning here is, contrary to the belief of a lot of people, the Common Core State Standards are not doing away with the need for students to learn basic mathematical facts. In other words, the addition facts, subtraction facts, multiplication and division facts. We are not doing away with those. But we are going to ask students to get to a deeper understanding, and we're going to ask them to be able to apply the mathematics that they're learning. In other words, we want them to understand mathematics in real-life situations. And finally, there is a great focus on dual intensity. In the past, we've had students practice with a great deal of intensity, but we haven't really had them getting to a point where they're understanding at a great deal of intensity, and that's really what we're looking at now with the Common Core State Standards. In real simple terms, there are 3 words that describe the central theme of the Common Core State Standards in mathematics: fewer, clearer, and higher. When we talk about fewer, what we're really talking about is the fact that in this country, in a given year, it was not unusual for students to have anywhere from 25 to 27 different major topics in their mathematics course study in a given year that they had to master. What we're doing now with the Common Core State Standards is using the kinds of things that we found those countries like Singapore and Finland that have outscored the United States consistently in mathematics, what they have done, and that is they've lessened that field of major topics to somewhere between 2 and 6. In the Common Core State Standards that we have adopted here in the 48 states that have now adopted this, we are down to somewhere between 2 and 4 major topics every year that we're going to be working with students. The second one of these is the concept of being clearer. If anyone picked up the old Illinois Learning Standards and tried to read through those in mathematics, it didn't take long before you were completely lost unless you were a trained mathematician. And there were times that even some of us got confused with what these were. These expectations are stated more clearly, and they're put in more student, parent, community member friendly terms, as well as teacher friendly terms. And the last of these is higher. And that addresses the fact of that we're going to go to a much greater rigorous demands on the students in terms of what the expectations are going to be for their understanding and their learning. When we look at the Common Core state standards, there are two major categories of standards that are addressed in the Common Core. There are standards of mathematical practice, and then there are standards of mathematical content. I'm going to talk briefly about the standards of mathematical content because those are the kinds of standards that most people are accustomed to use or seeing if you have actually looked at any of the standards in your state or in your school district. These are the things that tell what we actually expect students to learn on a day-to-day basis. They're spread across grade levels to ensure some sort of a seamless transition as students move from one grade level to the next. The major shift in design that you're going to see has to do with the first of these, and that is the standards of mathematical practice. When we talk about the standards of mathematical practice, what we're really talking about are habits of mind that we would expect mathematically proficient students to have. And so each one of these starts out with those same three words, mathematically proficient students, and then we talk about the standard itself. These things talk about what good math students really are capable and able to do. So the first of these, and I might point out to you, I'm using a set of posters that were developed by teachers in a school district in Jordan, Utah. The posters that you're going to see are ones that were developed by their kindergarten and first grade teachers for their students. There are sets of posters that also address second and third grade, fourth and fifth grade, and sixth grade. And those are available on the Jordan School District, Jordan, Utah School District website. The first of these standards of mathematical practice say that we want students to be able to make sense of problems and persevere in solving them. When we talk about that, what we're really saying is we want students to be able to tell us what this really means and what we expect them to be able to do. So the folks in Jordan have actually applied this to each one of their posters. It says, when given a problem, I can make a plan to solve it and check my answer. So their students can now look at these posters and know exactly what it is that they're expected to do. Both or all three times, before, during, and after they've actually worked on a problem. The second of these mathematical practice standards refers to the fact that we want students to be able to reason abstractly and quantitatively. When we start talking about abstractly and quantitatively and reasoning here, what we're talking about really are two major terms that we use quite a bit. One of them is contextualizing, and that is where we go from numbers to words. For example, we have the addition problem 2 plus 3 is equal to 5, and we've asked the student now to be able to say, how would you write that out in words? Can you give me a word problem that tells what that actually is? And this student says, I have 2 yellow flowers and 3 red flowers. How many flowers do I have altogether? If we went around and started with the verbal form and went to the numerical form, then what we're doing is we're talking about getting students to decontextualize so that they can read the context here in words and they can break that down into a numerical type of expression or equation. Third, we want students to be able to construct viable arguments and critique the reasoning of others. In other words, what we want students to be able to do is we want them to be able to explain the work that they do, explain what kinds of strategies they used, how they figured out what the numbers were that they were going to use, how they determined what the operations were going to be that they were going to use. But then we also want them to be able to listen to what others have to say about how they've worked a problem and be able to critique them in a constructive type way. We want students to be able to model with mathematics. In other words, we want them to be able to see an everyday life kind of situation so that they can actually use the mathematics that they know to be able to solve that. And this may involve drawing pictures, using the actual numerals themselves, using some objects, or perhaps even writing the thing in Word, so that they can actually use the information that they're developing there to solve an everyday kind of problem. The next one of these is we want students to be able to use appropriate tools in a strategic way. And what that means is we simply want them to say, I have certain tools available to me. For young students, it may be a number line, it may be pencil and paper, it may be unit cubes, it may be a die that has numbers on it. Older students, what it may be is a calculator, whether it be a scientific or a graphing calculator or a computer. So we want students to be able to use the tools that are in their toolbox and figure out when is the most strategic time and best time for them to use those tools. We also want our students to be able to attend to precision. When we talk about attending to precision, yes, we want accuracy, but we want to go even further than that, because what we want to do is we want to make sure that students are talking mathematically, so that when we're looking at a problem like this one right here, we know that a student is saying, if I have 2 cats and 3 dogs, then I can add the 2 together even though they are different kinds of animals, and I come up with a total of 5 pets. This involves the use of math vocabulary. We really want our students to be able to use the vocabulary of a mathematician and to use it correctly. The 7th of these strategies says we want students to be able to look for and make use of structure. And structure refers to being able to understand how certain things fit together. For example, when a student is given the number 11 and has to use some sort of objects to be able to describe what 11 really is, they may take a box that is divided into 10 equal-sized pieces and put 10 little balls or chips in those boxes. And then the 11th one sits out here. So that what happens is the student actually understands that 11 is the same thing as 10 plus 1. And so students start really learning the value of place value and understanding place value at a very young age. Because remember, these are posters that were developed by kindergarten and first grade teachers. In addition, we can teach them something about properties. The commutative property for addition is a perfect example of the bugs that are here. We have 2 of this style of bug and 1 of this style of bug. It's exactly the same as adding 1 of that second style of bug to 2 of that first style of bug. And then we can use shapes to teach them all about things like fractions and fractional pieces and wholes. And the 8th and final one of these standards for mathematical practice is that we want our students to be able to look for and express regularity in repeated reasoning. And when we talk about repeated reasoning, what we're really talking about is understanding and seeing patterns. In some cases, for example, kindergarten, first grade students, we may want them to simply be able to see that numbers like 11 is the same thing as 10 plus 1. 12 would be 10 plus 2, and so on. And eventually get to the point where they would understand that 25, for example, is 20, or 10 plus 10 plus 5. All the way to the point where when we start talking about multiplication, we want our students to be able to see that multiplication is nothing more than repeated addition. So how is this going to be applied at the different grade levels? Well, we've broken this down into the major categories where we find students in their everyday life at school. Kindergarten through 5th grade. In kindergarten through 5th grade, we want our students to become really strong in the basic operations, and that would be addition, subtraction, multiplication, division with whole numbers, fractions, and decimals, and then have some exposure to some real life application with those particular items. In grades 6 through 8, this would be middle school students, we want our students then to be able to get a lot of hands-on experience where they can actually touch and feel the mathematics that is going on in their room. And we want them to be able to do that through all the different domains of mathematics. At the high school level, we want our students to now become mathematical thinkers. And we want them to do that through real-life issues, making a strong emphasis on modeling and application. So what are things going to look like when the Common Core state standards actually hit? And our first assessments are going to actually occur for the Common Core state standards in the spring of 2015. At each grade level, students are going to be expected really to know and to be able to do more than they currently do. The level of rigor has been stepped up significantly. But in addition to that, these assessments are not going to be just multiple choice questions, which is what the majority of the assessments that students are currently doing are all about. They are going to include extended response, multiple step, as well as some open-ended problems in which students are going to have to actually explain and defend their answers. So these assessments are going to be a lot more complex than the assessments that students are currently taking. In addition to the fact that the whole world is going to change for the students, this also says that teaching is going to change and is going to have to change pretty significantly. Teachers are going to have to make use of multimedia. They're going to actually have to bring the real world into the classroom. We want our teachers to bring intuition into the whole concept of the learning in the classroom. We want them to actually make their students defend their work and their answers. We want to encourage students to ask the shortest questions that they can ask. Those questions might be why or how do you know? Because what we want students to really know is the mathematics behind what it is that they're doing. Many students are very good at doing the work, but there are not a lot of students who are that great at explaining why and how the mathematics works. That's what we want our students to be able to do. Einstein suggested that we have the students actually build the problem. Give them some little pieces of information and then say, okay, what do you see as the problem? What's the question here that we want to ask? And we want to encourage teachers to be a little less helpful in the classroom. Now this may sound a little bit contradictory to what we typically ask our teachers to do. But what we're really wanting to do, we're not asking teachers to never give students any information. What we're really wanting our teachers to do is to make the students dig into the mathematics and get their hands a little bit dirty and get it on the mathematics. I have listed here a few places where you can go if you would like to find out some more information about the Common Core state standards. The first of these is the Illinois State Board of Education website. You can go onto that website and find all kinds of information that the State Board is populating and adding to on a week-by-week basis currently. You can also go to a place called www.commoncoretools.org. This is going to tell you how the learning progresses through the different grade levels. And you can also look at a site that's called Illustrative Mathematics, which gives a good sampling of what Common Core state standards and mathematics problems are going to look like. Also, don't hesitate to Google the National PTA website. They have pamphlets available that address how the Common Core state standards in both mathematics and English language arts are going to be introduced and brought into the kids and what should be happening at every single grade level. In addition to that, don't hesitate to call the regional office. Our regional offices are both in Jerseyville and Carlinville, and I will be more than happy to address any questions that anyone has, or to even address a group. If a PTO would like for me to come speak, I would be more than happy to come speak to them. I thank you for your time and your attention. Have a nice day.